Okay, in this video we'll do a bit of review from vector geometry. As I promised, we'll do problem 14 from the final December 2012. Okay, and the problem says let P be a plane given by this equation, x minus 2y plus 2z. And then you're asked part A to find the distance from the origin to the plane. Part B, find an equation for the line through the origin perpendicular to P, to the plane P, and finally find the point on P that is closest to the origin. Okay, at this point I would like you to pause this video to try to solve this problem by yourself, and then if you get stuck at a certain point, come back and look at the video. Okay, so first of all, I would like to remind you of the if we're given a hyperplane in R3 with equation, or simply a plane in R3 with equation, so given a plane in R3 by the equation ax plus by plus cz is equal to d, then the distance between the plane and the point x naught, y naught, z naught, okay, is given by the formula the absolute value of the dot product between the normal vector given by the constants multiplying x, y, z in the definition of in the equation of the plane, and the vector describing this point, or simply a times x naught plus b times y naught plus c times z naught minus d. Okay, this sum is going to be put in the absolute value over the norm of the normal vector, which is a squared plus b squared plus c squared, and then we take the square root of this sum. Okay, well, what do we have then for a? We're looking for the distance between x minus 2y plus 2z is equal to 8, which a would be 1, b is negative 2, c is 2, and d is 8, and the origin is described as 0, 0, 0, is, well, just I apply this formula. So absolute value of a is 1 times x, so 1 times 0, plus b, negative 2 times 0, plus c, oops, how much is c? 2 times 0, right? Minus 8 over the square root of the normal vector of this plane, right? So the normal vector, right away you can write down that the normal vector is just 1, negative 2, 2. So that would be 1 squared plus negative 2 squared plus 2 squared. 0, 0, 0 minus 8 is absolute value of negative 8 divided by square root of 1 plus 4 plus 4, and that's 8. That's 8 over 9. Sorry, square root of 9. So finally the distance is equal to 8 over 3. Okay, and you can apply this distance for any question of the type when you're looking for, so this is a distance between a point and a plane, right? When we say the distance, we think about the shortest distance between this point and this plane. The same logic can be used if you have a plane and a line that's parallel to this plane. Just choose a point on this line, find a point on the line, any point on the line. You know how to do that. If the line is given in parametric form, then you just choose t and you find the point on the line. Then the distance between the line and the plane is just going to be the shortest distance. Again, this point and the distance between this point and the given plane, following this formula. or at the end, if you have two parallel planes, again, just choose a point on the plane here and find the distance between that point and the plane below using the same formula. Okay. Now the second question is, find an equation of the line through the origin perpendicular to the point, sorry, to the plane P. Okay, so now we're doing part B. So let's say that here we have the origin, right? A point with coordinate 0, 0, 0, and here I have the plane. That's called P, given by the equation x minus 2y plus 2z is equal to 8. Now I want to find an equation, parametric equation of the line that passes through the origin and it's orthogonal, it's perpendicular to the plane. Okay, let me just remind you that the equation, the parametric equation of the line is given by a point on the line x naught, y naught, z naught plus t times a, b, c, where x naught, y naught, z naught is a point on the line, and the vector ABC is a vector parallel to the line. Okay, so that's the parametric equation. Okay, so let's see what we have here. X, Y, Z is equal to, what is the point on this line that we know it exists? Well, it says find the equation of the line going through the origin. So the point is 0, 0, 0 plus t times this vector ABC. And this vector is a vector that is orthogonal, perpendicular to any vector on this plane right here. If the line is perpendicular to the plane, that means that the line is parallel to the normal vector. The normal vector is always orthogonal to the plane. But I know what the normal vector is. I can read it out from here. It's consisted of its entries are consisted of the constants multiplying x, y, z in the definition of the plane. So that's 1, -2, and 2. And then we just forget about this 0, 0, 0, because when we add it to this vector, this is what we get. Very, very simple. The parametric equation of the line passing through the origin, through the point 0, 0, 0, that is perpendicular to the plane, which means it is parallel to the normal vector of this plane. And finally, part C, find the point on the plane. So part C, find the point on the plane P that it's closest to the origin. So basically we're looking for this distance. If let's say that this is the line, okay, what we're looking for here is how much is this point here. What is this point? Well, the point belongs to the plane, right? So this point belongs to the plane P, which means it satisfies the equation x minus 2y plus 2z is equal to 0, 8, sorry, but also belongs to the line that we found in the previous question. It belongs to the line xyz is equal to t times 1 negative 2, 2. But from here, it means that I can express what is x in terms of the parameter, that's why it's called parameter equation, in terms of the parameter t. So x is t times 1, y is t times negative 2, and z is t times 2. Okay, so this point is described by these equations, but also belongs to the equation of the plane. So if we substitute these values for x, y, and z in terms of t in the equation of the plane, then we will have equation only in one variable. It's going to depend on the parameter t. So instead of x, I put t minus 2 times y in terms of the parameter t is negative 2t, plus 2 times z, z in terms of t is 2t, and that's equal to 8. So this is very simple. T plus 4t plus 4t is equal to 8, and from here t is equal to 8 over 9. Okay? Because the equation of the line depends on the parameter t, it would be the easiest to plug this parameter in the equation of the line, and then that will describe a point on that line. What point? Exactly the point where the line intersects the plane. So the point of intersection is x, y, z, which is equal to 8 over 9. Right, so I'm plugging t in the equation of the plane, so that's negative 16 over 9, negative 2 times 8 over 9, and 16 over 9, which was obtained when I multiplied t is 8 over 9, 8 over 9 times 2 is 16 over 9.